Let's talk about this program. And we have a monster class. Let's take a look at the monster class. Monster class has instance variables height, weight, age. We have monster, constructor, the default constructor, one that takes the height, one that takes height and weight, one that takes height, weight, and age. And we have set age, and we have the toString that prints out the height, weight, and the age. Let's go to the main. We start out with creating a new monster and sending 10 to, 10 to the height and 10 to the weight. Right there. So monster y equals x. So y is going to get x's address. So if we say, are they equal to each other? It's going to say true. Yes, they are equal to each other. They have the same address. But then if we give y a new address, right there in line 9, now y doesn't have x's address. Y has its own address. Now it's going to say false. Those are not equal to each other. But then we can create the dot equals. Notice that the last line right here, do they equal each other? That's going to say false. No, they don't equal each other. And so we want to create the dot equals to make that true. Now we'll do this with public. We're going to return Boolean. We're not returning the monster. We're going to override the equals method, and we're going to do, we're going to get an object, and we're going to do other. Now this is the way that Java actually does the dot equals. Actually, we can say this is, let's go with the temporary one, object, spelled object wrong. Well, then they cast temp as a monster. So monster other is equal to, and we cast the object as a monster. Temp. Temp. There we go. So that's how Java actually does it. We could just have the parameter as a monster, but that's not how it's done by Java. Now we want to say if, how about we go if height is equal to other dot height, and then we go end weight is equal to other dot weight. Then we're going to return true. Otherwise, we're going to turn false, and I know I have a mistake up there. We need the double equals there. Now when I run it, this last false right here in the output should say true. Let's see if it does it now. Oh, I got a mistake somewhere. Other wait. Oh, why did I spell it like that? That was silly. And we have this right here. Another one return false. I'll get this. Return false. And now it says true. Those two monsters are exactly the same. Well, now we can make an array of monsters, not an array of strings, not an array of integers, but an array of monsters. And so we can create 7 monsters. Fills array with null. So if we print this array now, notice that everything is null. So we don't have new monsters. We have a new array that can fill with monsters. Let's go down here. Note the objects are created, but the array holds the memory locations. So we're going to create the monsters. And when we run them, now it says it holds the memory locations. Well, that's if, let's do this. Let's take, if we comment out the toString, then now when we run it, it's just a bunch of memory locations. There we go. But if we make the toString, excuse me, then we're going to override the toString. It won't print out memory locations. It'll print out the actual values that we sent. And we'll see what we saw before where it actually has the value, because now it's using the toString that we created and it knows what to print. Let's set index 2 to a monster. Set index 2 to a monster. and then we'll print the list. Let's go down here. It says memory locations. Create toString to print out usable data. We kind of did that. We put it back in. But now to give location to index 2 a monster, we'll go list 2. That equals a new monster. Equals new monster. And we could do the default, or we could give it values. How about 20, comma, I don't know, 25, something like that. Now index 2 will have a value. And did we print it out? Oh, we called print array, and that calls this right here. And it lists it out in a more readable way. So now we see index 2 actually has a new monster right there with the values that we sent it. Memory locations printed unless we do the toString, which we did that. All right, now we call a method called set. We're setting the age at 2131 and set 1 to age 777. So we can call methods within the monster class using each individual element of the array. So now when we print this, let's look at list 0 and list 1 has new values. List 0, list 1, their ages are both 200. Now it should be much different. Oh, pulling, somehow I got, oh yeah, I lost, yeah, didn't drag that down with it. That's not it. Where's asterisk? There it is. Got it. Now this should work, and we're seeing that 0 and 1 have different ages. 2131 and 777. If we try to set the age, let's pull this down to, let's pull it down to here would be fine. If we try to set the age for the third index, notice third index is null. We can't do that because there's what's called a null pointer exception. It means we're trying to use something that doesn't have a value at all. It has a null value, and we can't do that. So let's comment that back out so we don't get an error. And now we can use a for each. That's what this is, for each, to print out the array. Well, it looks a little, well, not odd, but you just don't get that list 0, list 1, list 2. You just get all of these objects. And it does the same thing, except for a for each, it'd be a little harder to print out list 0, list 1, list 2, but we could get the job done. We just have to have a counter. We'd have to have an extra variable to count which index we're on. And finally, on this, we have what's called the split command. So if you say string S is the quick brown fox jumps over the lazy dog, which has every letter in the alphabet, then we can put each of those words into the individual element of the array by using what's called the split command, and we tell it to split it over the spaces. So when we print the array, it has all of those words. The quick brown fox jumps over the lazy dog. Each word is in the individual element of the array.